Okay, guys, welcome back. So, looks like I've got a number of messages about the 9:30 start time that a number of you have class conflicts with another class that also starts at 9:30 or one that starts at 10:30 for some of you. So what we'll do is we'll have to continue this in future weeks. We will start at 8:30. What I will do though is anytime I give a quiz on Tuesday, I will make sure that it will be in that first hour in the 8:30 to 9:30 time frame, so that those of you who have other classes, other class conflicts, that you will be able to join the quiz at least for sure. Okay, so we'll just have to do it that way, and yeah, so we'll continue with as the schedule is put on here, the 8:30 to 10:30 time in future weeks. All right. So let's go ahead and get started for today. Back to our introduction. Is it sharing? Okay, so you guys, all right, so the slide's over here. All right. All right, so this is where we ended, was we talked about what a database is. And what I would like to do is go ahead and continue on into, so what is a database management system? So, one of the big parts of all this, the big component of what we're going to be talking about is how to design a database. And the DBMS is going to be what we're going to use to be able to define and create and control access. Everything is going to be handled by the DBMS, where we are not going to we're not going to have our programs control the data like in the old file-based system, but instead what we're going to do is we're going to have a database management system control all the data and control access to it as well. The DBMS will also be able to be used for security purposes, to be able to make sure that certain users have access to the things that they need and not to the things that they don't need. Okay, and then we will also have, as part of the DBMS, there can also be an application program, something that we can use to be able to interact with the database and be able to run our SQL statements and be able to do things that will make data viewing and data manipulation possible. A very what is it? Very complex program, not a complex, but a very powerful program called Toad is what I used when I was working in industry to be able to access an Oracle database. For those of you who have downloaded and installed the Apache server, the WAMP or MAMP or LAMP, or something like that, the MySQL program, and started playing around with that. That's your application program too. You can use a web browser to be able to do the application program as well, to be able to access the database. Has anyone had any difficulty? Has anyone been able to install that, or has anyone had any difficulty being able to install that and get it running? Let's do this. I actually don't answer in the class. I just realized what I would like you to do is go ahead and this week, sometime before the end of the week, try to install a MySQL application like a WAMP or whatever, and try to get that running on your system. And if you have difficulties, contact me, and what we can do is be able to I can walk you through maybe during next week's class how to install and get it set up, because that's what I'll go ahead and do on Monday of next week for sure. All right. There's a question, MongoDB. If that's an SQL-based database, then you'll be able to use that right alongside with what we're doing in this class. And everything that we do in this class will be able to be run by that. I've not used that before, so I'm not sure if that's SQL or not. There are some other NoSQL databases that students have used. The main thing with that is if you use something like that, then you'll just have to learn a different way of interacting with the database than SQL. But this class is based on SQL, so you'll have to learn both, right? So if you want to take the time to be able to learn both ways of doing it, then I have no problem with that. But know that your assignments, the midterm exam, the final exam, will all be based on, as far as how to interact with the database, will be based on SQL. Okay, all right. So, I mean, I would imagine that I would personally go for the newer one, just because I like having the newest stuff that's available to me. But make sure it's not a beta version that hasn't been thoroughly tested, is what I would say. And so if 5 is the most recent stable version, then I'd probably go with that. But if 8 is a stable version, then I usually opt for the newer thing in these things. So, okay. All right. All right. So remember what we looked at yesterday. What we looked at yesterday was where you had the sales and the contract system both had their own user interface, both had their own set of data files as well. But here instead, what we're going to do is we're going to have this database management system that's going to interact with the database. Now, the sales will have their own program still, but the program doesn't control the data, have its own data files anymore. Now, instead, it's going to interact directly with the DBMS that then will be in control of interacting with the database itself. Okay, and contracts also will have their own application programs that will interact with the DBMS. Think of it like this, that if instead of sales and contracts, if instead what we had was maybe something like if you were on Sahib Indin. I'm assuming most of you guys have used Sahib Indin before, or at least seen it. And you can imagine that we'll have owners of properties like, apartments and stuff. And then we also have users, standard users of Sahib Indin, right? Now, we want them both to be able to look at some of the same information. We would like the owners to be able to have access to look at apartments, right? Because we want them to be able to add an apartment to the system for rent. We also want users to be able to see the same information, but we don't want them to have access to all the same stuff, right? For example, we want the owner to be able to say what the rent can be. We want them to be able to change what the rent of an apartment is, right? But the user, we don't want them to be able to change the rent, but we do want them to be able to see it, right? We want the owner to be able to change lots of information, maybe change, we want them to be able to have certain controls over things. We want them to be able to set, how big an apartment is. Is it a 4+1? Is it a 3+1? Things like that. We want the user not to be able to control that, but we do want them to be able to see it, right? And so we need them to be able to have access to the same information, right? But maybe different types of access. Okay, and the DBMS will be responsible for making sure that certain users can change information and certain users can only view information. And there might be some information that we want some users to be able to see and change, and we might want have the same information that other users can neither see nor change. For example, we might want you an individual user even to be able to see and change their password to a system. We don't want anybody else to be able to see or change your password, right? We definitely don't want them to change it, but we don't want them to see your password either, right? All right. So this is going to be stuff that the DBMS can control, and then that way the application program, we can really kind of make it focused on the user interface aspect, making it easy for the user to use, and that way it's not also dealing with data manipulation and data control. Okay. All right. So our database approach, we'll have two types of language that we'll have access to. One is the data definition and one is the data manipulation. Now, the data definition language is going to be used to tell us how we can make our data types and how we can control our structures. It's not about the data itself. Okay, this is not the data itself. This is how it's going to be stored. So if we think about it, the data definition would be like the class in a Java file. Like we're going to create the class that's going to tell us how the structure is going to be, right? Okay, so what are the different variables? It's not the data itself, right? It's not the values itself. It's just how the values are going to be done, right? Data manipulation language, on the other hand, is that how we can see the data. So the seeing the data will, if you think of it like a getter or what's called an accessor, the fancy word is accessor in our object-oriented approach. But the getter, right, where we can see the information, this would be part of the data manipulation language. We can also do a setter where we can change information using the data manipulation language. So the DML part of this is going to be for seeing, changing, manipulating the data itself. Okay. One of the nice things about SQL is SQL has both of these in the same setup. Okay, so SQL, you don't have to have two separate languages. It's all part of one package deal. Okay, all right. So some points of what we might want to have as part of our database approach is we want to make sure that we have security. We want to make sure that we have an integrity system. Integrity is basically making sure that the data is the right, there's certain aspects of the data that are, gosh, the more I learn Turkish, the more I lose English sometimes. I'm sure you guys feel that. And kind of the concept of integrity is making sure that we don't have like missing links. Like if, for example, we'll talk about referential integrity, when we talk about normalization, and that's making sure that if a certain part of our database says that a property, so like as an example from our property, we'll keep coming back to this this what's called the Dream Homes application. So if we say that a property exists, we should make sure that we have an entry in the property table for that property. And that would make sense, that if we expect something to be there, it's actually there. Integrity could also make sure that data types are proper, that we don't have a string where a number should be, for example. Okay, and things like that. A recovery control system, so making sure that if data gets lost unnecessarily or accidentally, that there's a way to get that data back, that there's a way to get that information back. Sometimes we do that through storage, through like data storage, tape backups and stuff like that. But there should be a way to be able to get information back if it's lost. Okay. All right. Some other things we'll talk about in this class, in this semester, is making sure that users have their own view of the database. Again, this comes back to kind of like where we only want users to be able to see the things that they have to see. So we don't want normal users to be able to see information that owners should see. We don't want Yeah, we don't want people to have access to things that they shouldn't, and we want to make sure they have access to the things that they should. Right. So that's in any type of system, you want to be able to have that type of security, and views will allow us to do that. And we'll talk about that when the time comes. But just some examples of some benefits of views, reduces complexity. We get a level of security where user will only have access to certain things. We can customize the appearance of the database. So, for example, we might not want every column in a certain table to be visible to a user, not because we don't want them to see it, but just because it'd be too much information. It'd be a lot of extra information that they don't want to have access to, that they don't want to have to deal with because it's not important to them. Okay. Yeah. And views being dynamic is that they can keep seeing the same thing, right? Even if something changes in the underlying database, even if we add a column or we add a table to the database, the user, if they don't need to see it, we don't have to show it to them, and so they continue to see things the same way they've always seen them, even if the underlying structure changes in some way. I can tell you that you probably have visited multiple websites, like we talked about Hepsiburada, Saibenden, Google, Amazon, all these websites, their database might change, but we don't really see that a whole lot as users. We don't see a lot of changing on the user experience because they keep that structure, what we see, the same, even though some of the database behind it might be changing. And views allow us to do that, and you'll see why when we talk about views in a few weeks. All right, some of the components that might exist in a DBMS environment. All right, so any computer-based component is going to have some type of hardware. We're going to have servers involved that will store the actual data in a database format. We'll have some software that will interface with the hardware. So this includes the DBMS. This includes the OS. This includes all kinds of stuff. All right. People will interact through procedures, right? A lot of this will be also types of software as well, right? But there's a human side to this, and data, and the machine side. Okay, so if you want to see it like in a bullet point format, some of the information there that any DBMS environment will have these main components, and even people are part of this. We are involved in providing the data, in viewing the data, in manipulating, changing that data, and so we are even part of a DBMS environment. All users are going to be doing things. So we have a database here at the university that includes your information as a student, includes the information of this course and other courses, and you interact with it. I interact with it. So we are part of this whole environment. Okay, and the programmers that program it and control it, they are also part of this environment. So if we see about who the people are involved, data administrator doesn't show up a whole lot, but a database administrator, I can tell you that any industry, any major company is going to have a database administrator role. The DBA will be in charge of making sure that people have access to the things they need, and make sure that they don't have access to the things they don't need. They will also be in charge of making sure that things run efficiently. The database administrator at the last position that I held, I can remember him constantly. He was running reports on the the network, like he was monitoring the network to see how fast the database was running, and he was constantly looking for what we call bottlenecks. So I would have, if I had a bottle, I don't know if you guys can see me on the camera, but in a bottle, the neck of something is where everything kind of slows down, right? So if I were to try to pour a water out of a bottle, right, there, the bottleneck is where it would all have to get to be able to get out. Well, that's going to be the slowdown, because if it wasn't there, if there was no neck, this water would just dump out, right? So in the same way, sometimes there can be things, certain aspects of the way that the application is interacting with the database, that there may be a certain query or a certain thing that's causing a slowdown, right? And so a database administrator will look for those, and he or she will try to figure out how to help make that run faster. Okay. There's also database designers, people who will control the logical and physical approaches of how to design the database. Application programmers. So there will be many more application programmers than database administrators. Some of those application programmers will be in charge of writing the database program, especially if you use a tool like Toad or anything that allows for stored procedures. Then you'll have application programmers that they will write the database part of the program. You'll also have application programmers that will be in charge of writing the user interface portion. We refer to those as front end and back end. So front end is the thing that the user sees. It's the front part. It's what they see at the very front. And so the front end is what the user uses. The back end is the database itself, is the database and the database management system itself. Okay, so sometimes you'll hear people say something like, we have a Java front end and an Oracle back end. And what they mean is that their user interface is written in Java and their database is an Oracle database. And so there's all kinds of ways that you can change that out. You could have a Python front end and a MySQL back end, right? And so you can have all these different combinations of ways that you can have a user interface language and a database language. Okay, and then finally, end users. All right, we have naive and sophisticated end users. Naive are just the typical user. So I would be considered a naive user of like Pepsi Boda, Gitty or those types of places. Sophisticated users would be those who are more kind of the administrative roles, your managers and stuff like that. All right. So there's a history of database systems. The focus of this course is going to be this second generation, the relational database system. There is object relational and object oriented. We'll talk a little bit about that towards the end of this semester, but really the focus of this course is helping you understand the first and second generation of database systems. Okay. As we've talked about before, there's advantages and also disadvantages of any new system. All right, so some of the advantages of database management systems, especially this is a big one, the control of data redundancy, making sure that we don't have multiple copies of the same data, which also will impact data consistency, because if we only have like, for example, if your name is only stored one place in the database, then there's not a chance that it might be spelled differently somewhere else. Because if it's only stored one place, it can only be spelled one way. Okay. Yeah. So data consistency can be a problem if we store the same information in multiple places, because what happens if it's stored in one place in one way and stored in a different place another way? For example, let's say if we had a person table and a student table, and your information was in both of those, and both of them had a birth date column, and in one place your birth date was one day, and in the other place your birthday was a completely different day for some reason. Well, which day is your birthday? Well, we wouldn't know because there wouldn't be consistency. Right? But if we store that data, if we store that birth date in one place only, there is absolute consistency. Now, it could be wrong, right? But at least it will be consistent. And if it's, and hopefully it's not, hopefully your information is one place, the right information, in that one place. Okay. Just some of the other advantages here. I don't want to spend too much time on this because we're supposed to get to slides 3 today as well that I've uploaded. Okay, so lots of advantages, lots of increased productivity. I don't want to gloss over though. I don't want to skip the disadvantages though, because every new thing, there's an old thing we call it. There's no such thing as a free lunch. What that means is that you don't just get good things all the time. There's always going to be some downside, or usually, I shouldn't say always, but there will often be a downside. And one of the disadvantages of a DBMS over, say, an old file-based system is, let's say that you have an old file-based system and you've written all the code for it and it works. It's okay. It's slow. It's clunky, but it works, right? Well, you get a new programmer who just graduated from Octonese University, and she comes into your company and she says, we need to stop this file base. We need to have a database because it would be a lot faster and it would be a lot easier to maintain, and there'd be a lot of benefits to, because what she does is she comes and she says, look at all these advantages of what we could have if we had a database instead of this old file-based system that's really slow and problematic. Well, you know what her manager might say is, okay, great. Well, how much is this going to cost? And she starts looking into, well, we'll need a database server. So there's a hardware cost. So we'll have to buy a database server. Okay. And we'll need to get a database system, so a database management system. So, we'll have to either buy an Oracle license, or we'll have to get MySQL, and we'll need to hire some people who know how to write database code. So we'll have to factor in the cost of the salary of those people. Okay, and oh yeah, we'll have to also convert the data from the old file-based system into the new database system. So that'll take some time. And what the boss is going to be saying is, you're telling me I need to spend a lot of money, right, to get to this new system. And managers and bosses and owners of companies, they don't like spending money, they like making money. So what our programmer will need to do is she will need to say, you know what, let me show you though that there will be a long-term gain. Okay, an immediate cost, yes, it will cost something immediately, but man, over the years ahead, we will save so much more, and our system will be faster, and our system will be better, and our system will be more efficient. And if she can show that, then the boss may be more able to say, okay, I can spend that money up front to be able to get the long-term gains. Okay, but these things, they do not come free. All right, switching over to a database management system way of doing things does not come free. In fact, this whole cost of conversion, my first full-time job in the industry was as I did a conversion of data from an old system into a new system. And we had a rather large client, and our company created we maintained a user interface and database system for this client. Well, they had multiple locations where they tracked stuff like their equipment. They were an oil refinery is what they were. And They had different types of equipment that they needed to track, and they needed to see, you know, how long it had been in service and all kinds of different information about it. Well, my job was to take the old data. Like what we would do is we would take a refinery. Let's say if this was in Turkey, let's say we're taking a site from Izmir, for example, and we're saying, okay, we want to take all of their data and we want to convert it from its existing format into our database format, and we want to basically have it one day, all the workers come in, they're using their old system. The next day they come in, they're using the new system. Okay, that's what we would like to have. The problem with that is that it takes time to figure out how to convert the data. Some of that data that we got was in text format, like notepad documents. Some of it was in Excel spreadsheets. Some of it was existing database like Microsoft Access and stuff like that. And it was all just not consistent. There wasn't a lot of consistency. And we needed to bring it over into a consistent database. Well, the thing is, you know, when you have thousands, tens of thousands, hundreds of thousands of rows of data, of information that you need to bring over from an old system to a new system, that takes a long time. In fact, it could take up to 3 months for us to get all of the information across correctly, right? So you can't have an oil refinery site. You can't have that thing shut down for 3 months, right? That's just not really an option. So what we would do is we would get what's called a data dump. We would get the entire, all their data on day one. And we would go through the process of converting that data. We would spend 3 months, we would be given 3 months to figure out how to convert all of that data over into the new format, into our database. And at the end of those 3 months, I'd have written all these SQL scripts and all these this way of taking the data and changing it into the correct format. All right. So then you'd think, okay, so then after 3 months, they shut down for a day, you run the scripts, and everybody's happy, right? The problem is what's happened in those 3 months. New data has gone into their system, right? Equipment has had to be replaced. Equipment's been checked, and the old values of, you know, whatever, you know, information about that equipment has changed over those 3 months. So what we would do is after those 3 months, we would get a new data dump, and then we would shut down, and we would be given no more than 3 days to get that data into the new format. Because the problem is some of the new data that's come into their system, our scripts didn't account for. It's in a format we didn't account for, you know, or whatever. And so then what we would do is we would convert it. They would shut down for 3 days only, usually over a weekend. And then they would basically come in on a Monday morning and the new system would be up and running. Okay. But it costs money, right? It cost to make that conversion. They had to shut down a refinery for 3 days. That cost the oil company something. They had to train their employees in how to use the new system. That cost them something. But what they believed and what we believed as well, and what I still hold to, is the new system was better than the old, and in the long run would save them money and would be much better for them. Okay. All right. So, but all that's to say, switching from an old system to a new system can come with some disadvantages, and we don't want to ignore those, but we do want to make sure that we understand that if we've done an analysis and if in the long run we're in a much better situation than in the short term, then we need to go ahead and make the switch. All right. So, yeah. How will I do this? Normally I would do this on the whiteboard. Do I have whiteboard available? Let's use our last few minutes to kind of analyze a system. Just realized I didn't pull up the whiteboard. Hold on. Let's see, where's whiteboard? There we are. Okay. Whiteboard should be coming up. Okay. Let's see, that's something left over from previous class. Okay. So the idea is we want to analyze a system. All right. So, actually Notepad might be better for what I'm trying to do right now. All right. All right. So we want to analyze a system like IMDb. All right. So IMDb is an example database. What kind of stuff does that track? Like what kind of categories of information do you find if you go onto IMDb? What do you think? Yeah, genre of like a TV show. Good. You guys are getting all kinds of good examples. All right. Let me see. Yeah. Let's see. Where are you? What? Trying to find the. There we go. All right. So genre, yeah. So it's like a genre. Type would also be genre. I'm assuming Muslim, right? So the name is that what kind of name? Like a person's name? A movie's name. So like title, right? So title, right? All right. Actors, directors, good. Actor, director, budget. So how much did the movie cost? Points. Anything else? Is that it? Income. Oh, how much did the movie make? Yeah, so like what would they call that? Box office receipts or the income, or money, right? We can call it. Oh, awards. Yeah, what kind of awards did the movie get, right? Oh, runtime. Yeah. Length, like how long is the movie? Nominations. So yeah, was it nominated? Nominations for awards, right? So now notice that some of this stuff would be what we would call an atomic value. So it's a single value. So like the title of a movie is one thing, right? So like title of a movie or a TV show. So I don't know if you guys have seen this one recently. My son's really been getting big into this one, right? WandaVision. He really likes this show right now. Right. So, it has a specific value and a specific type. It's a string, right? Right. piece of text. But what about actor? Would that be a one value, like, or is there more than one thing that might go under actor? Like, what kinds of things would we include as part of an actor? Does the question make sense? Yeah, like what type of actor they are. But I mean, like, for example, if I were to say what type of information might be stored in a database for you as a person, is there really only one thing that makes you? Yeah, right. What I mean is it's a category. Really, actor is a type of category, right? And let me show you what I mean by that. An actor has a lot of different parts, right? An actor has a name. An actor has a birth date. An actor has a gender. An actor has possibly a death date, right? For example, if an actor is no longer alive, right? They have a date of death. They have what else? They might have things like education. Education, like where did they go to university or school? You know, education. And I would spell that word wrong at first. They have a list of awards that they've won. They have a list of marriage status. Yeah, right. Are they married? Are they single? Are they divorced? You know, what's their status? So notice that all of these, to a degree, education is kind of a different one, but marriage status, date of death, gender, birth date, name, these would all be considered atomic values, right? These would all be considered a single value. You're not going to have, now, they may have aliases, so actors may be known by more than one name, that's true, but for the most part, their name will be a single string value. Their birth date will be a single date value. Their gender will be a single specific value, right? Their marriage status will be a single value. So actor is really kind of a category that has a bunch of attributes, right? Title for a movie is not a category because it really only has a single value. Right? And so notice, where would we put title? Title would come under what type of, it would be a category, right? Under maybe movies. So movie would have a title. Notice we could also, we might take title and put it down here. Notice a movie would also have a genre, right? A movie would also have a runtime. So notice what we're doing is we're taking, right, we're taking some of these things these attributes that we have, that we've listed of the things that we want to track, and we're trying to categorize them. We're trying to put them into individual categories below. All right, income, I think that was a movie thing, right? So what we want to do is we want to start up here with just a whole list, a whole ton of attributes that we want to keep track of. And the way we might do that, let me see here. I'm going to pull up a Google Chrome here, and if I go to IMDb, have you guys all been there before? Have you ever gone to? Has anybody not gone to IMDb before? Okay. So here, if I go through IMDb and I say, okay, you know what? That is a Disney movie. That's good, right? And if I just say, okay, I'm just going to go through here and I'm just going to say, oh, okay, it's got, what does a movie have? A movie has a rating, a title, a year that it was released, how many stars does it have, what is its genre over here, what is its release date. And what I would do is if I was trying to design this system, I would say, okay, I would go through and I would say, okay, what are all the things I'm trying to track? And I would just list those out and I would make a big list of all that, all right? And say title, and don't write soul, because soul isn't what I'm tracking. Soul is the data that I'm tracking, but it's not the category, right? The category of what I'm trying is title. It's a movie title. And I would say, okay, what type of things? Title, rate, age rating, runtime, genre, as you guys suggested, release date, which I didn't include here. Right. Oh, a description, right? What's a description? Now, when I get to something like directors, though, is I might say, well, you know what, though? That director, yeah, that's a person, but man, that's going to be this Pete Doctor. He's going to have all kinds of information himself, like name and age and birth date and marriage status, as Torana suggested, right? And stars, that'll be the same thing, right? So what I'm going to do is I'm going to then say, okay, let me go over to the director, or let me go over to the stars, Jamie Foxx, for example. Okay, so I'm going to pull up Jamie Foxx, and I'm going to go through and I say, oh, okay, who's this guy? Like, what kind of information are they tracking for him? His birth date, his birth location, maybe a description of who he is, a bio. We call it a bio. All right. Photos. Oh, they got photos of him. All right. Oh, what movies has he been in? Right. So these are all things that we would track for this person, for this actor, writer, producer. And so what I'm going to do is before I start going into this area here, first I'm just up here and I'm just making a list of all the stuff I'm tracking, right? So movie title, movie runtime, actor name, actor birth date. Like, I'm just making a huge list of all the attributes that I want to track, right? And then what I'm going to do is I'm going to take those attributes and I'm going to try to put them into a category. So I'm going to take that actor name and I'm going to say, well, that could all be going under actor. I'm going to take that actor birth date and I'm going to put that under actor. And I'm going to take gender and marriage status and I'm going to put that under actor. And same thing with movie. I'm going to take all the stuff I got from that movies page, the title, the genre, the runtime, and I'm going to put that under the movie category, right? And what I'm going to do is I'm going to take all of my attributes and I'm going to eventually get them under some category, right? So director would, like actor, be its own category because it represents a person. And notice that the director will probably have a lot of the same stuff here, right? So I'll just put that there, right? Budget, that was a movie thing, right? Points, that was a movie thing, right? Awards, that was a movie thing. Nominations, that was a movie thing because that was like with awards. So awards, and what we could do is say awards and nominations, right? And so once I have all of my things that I'm tracking, all my attributes in a category of some kind, I can feel like I've done a decent initial first job of trying to analyze the system to help me understand what the system is supposed to look like. Okay, trying to categorize things. This is part of the analysis of a system. And the reason why I'm getting into all this, the reason why I've gone through all this with you with IMDb is because this is your first homework assignment. All right. So you guys, it shouldn't take you very long. You're right, Tarana. Yeah, absolutely. You could have an awards and nominations under an actor and a director. IMDb is actually a much more complex system, the way it's probably designed than you or I might think it is. But yes, awards and nominations could go under both. Yeah, exactly. There's a lot of shared attributes. So the way that we want to store that is, how would we do that? Be very difficult and complex to analyze. But I just want you to make a first pass at this, okay? So let me see if I have included in here. I don't. Okay, so your homework is to analyze a system. You can't use IMDb because we did that one in class, okay? But choose a system that you think probably has a database behind it. It could be, just some ideas I'm throwing out there. It could be this university system for Octanies. It could be Migros. It could be Sahib and Den. It could be Tepsi Borda. It can be lots of things. It could be a banking system. If you have a bank account, go try to tackle your bank. Like me, I have a TEB account, a TEB bank account that the university gives me, right? Try to tackle that and see how a banking system might be analyzed. There are some requirements. You will have to have, I don't have it in front of me. I meant to include it in the slide and I totally forgot. But you will have a minimum number of attributes you have to do, and then you'll have a minimum number of categories that you'll have to group them into. So basically, I think the way I did it was 40 attributes minimum and 5 categories minimum, or 6 categories minimum. I'll look at it because I have the assignment as a PDF from last year that I'll re-upload. But basically, if you don't have enough attributes, then you are not thinking across the system broadly enough, right? And if you don't have enough categories, then you're not thinking deep enough in the system. So I want you to make sure to kind of think across both broad and deep to make sure you kind of analyze a good solid system. Okay, because the truth is, I could get 40 items, 40 attributes off of just of that movie page, probably off of that one movie Soul. I probably could have gotten 40 attributes off of that one page. But I don't want to just do movies. With IMDb, I want to be able to broaden my understanding to include actors, directors, awards, and other things like that. Okay. All right. You can show it however you want. If you want to do it graphically, where you draw like boxes, like a UML diagram style, you can do it that way, where you have kind of classes and attributes of those classes. If you want to do it that way, that's great. That's fine. If you want to just submit a Microsoft Notepad a text document with just like what I did in class here, where you had a category and then a list of attributes underneath that category, that'll be okay too. Just make sure it's clear what you're trying to do, and I will, yeah. So any of those formats are fine. Unfortunately, at this point, you won't be able to turn it in like on a sheet of paper by hand, but you can scan it. You could draw it out on a piece of paper and scan it and upload it as an image or a PDF. Okay. Like I said, today I will upload the what is it? The assignment description, and then you'll be able to have a better understanding of what's expected there. Okay. All right. Well, guys, it's 10:30, and actually that's probably a good stopping point since I gave you a homework assignment. So actually, we've covered a lot so far in the first week. So what we'll do is we'll go ahead and end there for today. I know we've only been on here an hour, but because of this class is only supposed to run 8:30 to 10:20. I'm going to go ahead and hold to that on the 10:20 end. But again, going forward, we will meet at 8:30. And like I said, if I give a quiz on a Tuesday, one, I will announce quizzes before they're given. No pop quizzes in this class. But the other thing is If it's given on a Tuesday, it will be during that first hour, that 8:30 to 9:30 hour, so that everyone will be able to join. Okay. All right. Are there any other questions or comments? Okay. All right, guys. Well, have a good Tuesday, and I will see you in just under a week on next Monday. All right. Have a good rest of the day.